Hi everyone. Welcome to the next video in our week 1 series. This video is on measures of location. So up to now, we've been talking about collecting and organizing data. Now we're going to start talking about how to summarize the properties of that data. A measure of location, also sometimes called measures of position in other textbooks, allow us to locate a data value relative to the rest of the data set. Also allows us to rank the data. So we know that when we're talking about ordinal data, interval data, anything except nominal data, that data is able to be ranked. Today we're going to cover a couple of specific measures of location. We're going to start with quartiles and then talk a little bit about percentiles. There are some more measures of location that will come up later, but this is our focus for today. Let's go ahead and start with bullet point 1. We're going to jump into quartiles. So the prefix quart is a Latin prefix, and it means fourth or four. So we know with quarters, we see quart in the beginning. It tells us we need 4 quarters to make up $1. We talk about quarter of an hour. We know we need 4 chunks of 15 minutes to make up a full 60-minute hour. Typically in schools that run on the quarter system, there's 4 quarters, fall, winter, spring, and summer. So we know quartiles have something to do with that number 4. Specifically in statistics, quartiles divide a data set into 4 groups of equal counts, meaning those quartile measures are going to take a data set and divide it into 4 chunks with an approximately equal number of data points in each chunk. To divide something into 4 pieces, we need 3 values. The first quartile, sometimes called Q1. The second quartile, which is also called the median, which we're going to talk about later in this series. And you'll see Q2 and MD used interchangeably. Sometimes the median is also called MED. And the third quartile, Q3. So we can see here a data set, 2, 4, 4, 5, 6, 7, 8, and it has been divided up into 4 equal chunks. The lowest chunk has 1 data point in it, middle chunk has 1, third chunk has 1, last chunk has 1. And those quartiles are the values in between each of those chunks. So what we're going to do is talk about how to find those. And we can do it by hand, sort of like this person's done here, or we can do it using technology. So in this example, our first quartile is 4, our second quartile, or our median, is 5, and our third quartile is 7. Those are where those dividing lines are, so that we get 4 equal chunks. Okay, so the question is, how do we find where those dividing lines are? If we want to do it by hand, first thing we have to do is sort that list in order. Remember, the example from the previous slide was sorted from smallest to largest. So that's our first step. For short lists, this is usually easiest to do by hand. If it's a long list, you can do it using a calculator, and that how-to guide is on Canvas. Once you've sorted the list, you want to find the number in the middle of the list. How I usually do this is I put my finger on the first value and the last value, and I move my fingers one by one towards the middle until my fingers meet. If my fingers meet on the same number, that's my median, or my second quartile. If there are 2 numbers in the middle, my fingers end up right next to each other, I need to find the value halfway between them. So we add them and divide by 2. What that means is sometimes your median is a number in the list, and sometimes it's not, and that's okay. Once you've found the median, you're going to draw a line where that median is. Then you're going to repeat that second step for the lower half of the list, all the numbers below the median, and then the upper half of the list, all the numbers above the median. And you'll notice those two steps have asterisks next to them. You don't want to double count your values. So let's go back to our previous slide. So in this slide here, we have 7 data values, 1, 2, 3, 4, 5, 6, 7. So if I cross them off pairwise, first the 2 and the 8 go, then the 4 and the 7 go, then the 4 and the 6 go, and my fingers end up together at 5. So 5 is my median. I'm going to put my dividing line there. That number has now been used. So when I go to find the median of the lower half, I am only using the numbers that are less than 5, the numbers that are not that median, so 2, 2, and 4, which is how we end up with that first quartile. In a list of 3, the number in the middle is the dividing line, the halfway point. Same on the upper end. If 5 has already been used for the median, I don't want to count it again when I'm going to find my third quartile. So it's not included, and I'm only looking at 6, 7, and 8. And I can clearly see 7 is in the middle of that list of 3. If it's a long list, or if, like me, you're sometimes lazy, you can do this using calculators or software online. My default is the TI-84, and most of these commands will work for any TI-84 model. Most of them will also work for TI-83s. If you have a TI Inspire, let me know. I have some guides for how to use those, but they're not very common, so I didn't put them in the notes. So if you're on an 84 or a similar model, the first thing you're going to do is put that data in a list. So to access lists, you're going to press the Stat button. And in the Edit menu, you'll see a couple of menus along the top of your screen. You want to select one, Edit. And then you're going to enter your data into that very first list, L1. Once your data is in L1, you press Stat again, and you're going to move over one to the Calc menu and select one var stats. When you do that, one of two things is going to happen. For most newer models, you're going to get some prompts. They're going to ask you where your data is. So you're going to enter L1 for your list, and to pull up that list name L1, you're going to press second and 1. So there should be a blue button, and then above the button 1 in blue, there should be L1. For the frequency list, you're going to leave it blank. We're not going to need that till later. And then you're going to go to Calculate and press Enter. When you do that, you're going to get a whole lot of information, and none of it's going to be quartiles. That's because it calculates a whole lot of things at once. You're actually going to have to use the down button on that arrow pad to scroll down to find Q1, the median, and Q3. My other preferred method for doing this is in GeoGebra. Of all of the online apps, I think this is probably the most user-friendly, and it has the most statistics functions. You can do similar things in Desmos if you're familiar with Desmos, but I definitely prefer GeoGebra. We start the same way. You have to get your data in a list. In GeoGebra, you need to give your list a name. Doesn't matter what you call it. I usually just use A. Equals, and then you're going to put curly brackets, and your number list separated by commas. So a name equals, and then your list of numbers in curly brackets. Once you've got that, you're going to press enter, and it'll move you down to the next entry box. And then you're going to run 3 commands on this data. First, you're going to type quartile 1, and then in the parentheses, whatever list name you gave your list. You hit enter, and it'll give you that first quartile. To pull out the second quartile, or the median, you're going to call median list name. And then, that next one, if you'll hang on a second, I will fix that, should say quartile 3. I'll try that again. Quartile 3 list name. On the TI-84, you'll notice there was a little asterisk here. If somebody else has been using your calculator, or if you've used it previously and played with the list menu, you may need to clear out old data. So to clear an existing list, you want to move the cursor up using the up arrow key to the top of the list so that that cursor is on the list name L1. Once your cursor is on the list name, you're going to press clear and then enter. If you accidentally press delete instead of clear, it's going to delete that list entirely, meaning your new list menu will start with L2. L1 won't be there anymore. It is possible to fix it. Way back in that first step where it says stat edit, the very last option is, I can't remember what it's called. Let me pull up my calculator and we'll take a look. Clear all that stat stuff. We want to go stats, and the very last one says setup editor. If you click that, it'll pull the command up and you just press enter to run it. And now when you go to stat edit, all of your lists should be restored. So let's say I go up here and I click delete and my list 1 is gone. I go stat, I go down to setup editor, enter and run it. When I go back to stat edit, there's my list 1 again. So typically if anything's gone wrong with your list menu on a TI, you want to go to stat and then down to setup editor. You'll also notice you can see sort ascending, sort descending, and clear list commands. You can do those, but you need to enter the list name. So if I want to clear specifically one list, I can select that, and then I need to tell it which list I want to clear. So let's say I want to clear list 1. I hit enter. The next time I open that list editor, you can see that list 1 is now empty. So that's another way to clear your list if you're afraid you're going to delete things. But you can clear it by going up to the list name and then clear and enter. Okay, so let's find some quartiles. I'm going to do this first one by hand, and then I'm going to use technology for the rest of this video. So find the quartiles for the data set: 15, 13, 6, 5, 12, 50, 22, and 18. To find quartiles, I know I need it in sorted order. So smallest to largest is going to be 5, 6, 12, 13, 15, 18, 22, and 50. Short list, so not too bad. To sort by hand, I did cross them off as I worked when I did this on paper. Don't be afraid to mark up your page and annotate to make sense of things. I'm not going to mark you down for any work that you're doing to make sense of a set of data. So to find the median first, we're going to cross off values from the outer edge, working our way to the middle. So 5 and 50, 6 and 22, 12 and 18, and you'll notice 2 values left in the middle. When that happens, we need to find the number halfway between. I can see it's 14, but I should check by adding and dividing by 2. So we now know second quartile, or median, is 14. Now we need to find the median for the lower half. That's our first quartile. Median for the upper half, which is our second quartile. So I'm going to put my dividing line. Notice it doesn't cross through any values. So this lower half is all 4 of those values up to and including 13. And for the upper half, it's all of those numbers including that 15. Using that same process, we cross off the outer edges to work towards the middle, and in both cases, 2 middle values. So 6 plus 12 divided by 2 is 9. So my first quartile sits here. And then 18 plus 22 divided by 2 is 20. So my third quartile sits here. And you'll notice that gives me 2 values in the first chunk, 2 in the second, 2 in the third, and 2 in the fourth. So those quartiles do divide my data into 4 equal chunks. So we're going to go ahead and try this with the TI-84 and GeoGebra to check your work, and I'm going to show you what that looks like. So let me go back, sorry. So we've got our TI-84 here, and I've already got it open to the list menu. I got there by pressing Stat and Enter, and I'm just going to type that data in. 15, 13, 6, 5, 12, 50, 22, and 18. You'll notice I'm just typing the original list in. I don't have to pre-sort. And then I'm going to press Stat, go over to Calc, and 1var stats, Enter. And I put my data in list 1, so second 1. And my frequency list should be blank, so I'm going to clear that. And then I'm going to go down to Calculate. And I get that big list of numbers, and that little arrow at the bottom tells me there's more stuff off the screen. And we can see, if I move this over, 9, 14, 20. So we got those same answers. Let's go ahead and try that with GeoGebra. So I'm going to pull my web browser out over here. Hopefully you all can see that. And I'm going to go GeoGebra Graphing Calculator. And you'll see an entry window and then a graph. For GeoGebra, the first step was to enter the list. So let me zoom in so everybody can see that there. So we're going to give this a list name. I'm going to call it A equals curly brackets, and then I'm going to type that data. 15, 13, 6, 5, 12, all the way down the list. Once I hit enter, GeoGebra is going to store that list in memory, and now I can run function calls using that list as data. So to get the first quartile, I'm going to type quartile 1, and you'll notice that prompt shows up. So I know that's an actual valid function call, and it gives us 9. To get quartile 2, I type median and the list name, and that gives us 14. And then to get the third quartile, I type quartile 3 and then list name. And so again, we get 9, 14, 20. So it shouldn't matter which method you use. You should get the same answer regardless. Related to quartiles is something called an interquartile range. That's a number that indicates how spread out our data set is. The IQR is the width of the middle 50% of the data. So the IQR extends from Q1 to Q3. We can use the IQR to identify outliers. An outlier is a value that is either more than 1.5 IQRs below the first quartile or more than 1.5 interquartile ranges above the third quartile. So we mentioned outliers in a previous video and we said extreme values. Now we know where the boundaries are that separate expected data from extreme values. So we're going to go ahead and do this example really quick. Following 13 real estate prices, calculate the IQR and determine if any prices are potential outliers. Prices are in dollars. I know for the IQR, I need the third quartile and the first quartile. So I need to enter this data into a calculator and find those quartile values. So here's my simplified table. And when I entered this list into a TI calculator, I got that the first quartile is 308,750 and the third quartile is 649,000. Once I have those, to get the IQR, I subtract third minus first. So 649,000 minus 308,750 gives me 340,250. So that's the width of the middle 50% of my data. To find the lower bound for outliers, we take that first quartile and we subtract 1.5 times the IQR. So 308,750 minus 1.5 times the IQR, 340,250. And that gives us a negative number. Looking at this data table, the smallest value that I see is a positive 114,950. So I don't have any values less than this lower bound. So there aren't any outliers on the lower end of my data. All of the lower values in this table are reasonable given the width of that middle 50%. We're going to repeat for the third quartile and our upper bound. Remember, on the upper edge, we want to add instead of subtract. And again, I found a typo, and I am sorry. I don't know what got into me. Let's fix that. When I did that calculation, I got 1,159,375. That was a mouthful. And I see one value in my table that is bigger than that 1.1 million, and that's the 5.5 million. So that value, which is almost 5 times bigger than that upper bound, is a potential outlier. I would say that's likely an outlier in my data. We need to identify outliers because those are going to help us make decisions about the summary statistics we want to use to describe things like where the measure of center is, where is our center of data, and how spread out that data is. Next chunk is percentiles. This is a little math heavy, and we're not going to spend a lot of time on it. So if anything I say in here is scary, try not to freak out. Percentiles are very similar to quartiles in terms of what they do to a data set. And we do have some hints from their names. That prefix per is not meaning fourth, and I don't know why I said that. Okay, fix that. Per is the Latin prefix meaning through, and then cent, right in the middle of that word, is a Latin root word meaning 100. So what percentiles do is they take all of our data and they're going to cut it into 100 equal chunks. So percentiles divide data into 100 groups of equal count, similar to how quartiles divide data sets into 4 groups of equal counts. There are some commonalities. The first quartile represents that boundary between the lowest 25% and the rest of the data. That's going to correspond to P25. The second quartile, or median, is the halfway point. So that's going to be P50. 50% of the data is less than, 50% of the data is greater than. And then that third quartile corresponds to the 75th percentile. So if you're asked for P25, P50, or P75, you already know how to find those. Those are quartiles. What percentiles do is they show us where that boundary line is between the percentage of data that's less than that value and the percentage of data that's above that value. So right here we've got a group of incoming freshmen, and we know that for that incoming class of freshmen, that the 75th percentile is 1,400. What that means is 75% of this incoming freshman class that took the SAT scored at or below 1,400. That then also means that the other 25% scored above 1,400. So percentiles are a way of comparing how you did relative to the rest of your class. The 1,400 tells you how you did on the test all by yourself, how many questions you got right out of how many questions there were. But the percentile ranking then tells you how you did relative to the rest of your peers. And so that's what percentiles are usually used for. They're used for comparisons among a population. You see them used a lot in school testing, SATs, SBACs, all of the state testing, all of that fun stuff. But you also see them a lot in doctor's offices, particularly when it comes to children and growth charts. They will look at your child's height periodically and check where they are at percentile-wise relative to other kids their age to see whether they are growing at a rate that is considered healthy. So percentiles are used a lot in situations where we need to compare people with their peers. There's 2 ways we can do this. We can go from percentile to the data value it represents, or given a data value, we can find the percentile that corresponds with it. Meaning if I give you a test score, you can tell me where I rank relative to my classmates. And that's what we're going to start with, how to find the percentile ranking given a specific data value, a test score, a height, something like that. So to do this, we're going to sort our data, just like quartiles, and then we need to define 3 variables. So we're going to let x be the number of data values less than the value of interest, less than that given data value. Y equals the number of data values in the data set that are equal to that data value. So this is how we're going to deal with any repeats in the list. If the number of interest, that given data value, only occurs once, y is 1. If that data value repeats twice, y is 2, and so on. The last is n, which represents the total number of data values. And we're going to use the 3 pieces of information to predict what that percentile ranking is. So to calculate the percentile, we take the number of data values less than the data value we're given, and we add to that half of the y value, half the number of repeats, and then we divide that by the total number of data values. Once we've done that, we're going to multiply it by 100 to turn it into a percent. And what this fraction represents is the amount of data that is less than the data value that we're given out of our entire data set. If we want to go the other way, the process looks a little different. So if we want to find the data value that corresponds to a specific percentile ranking, we need to do that process backwards. We know where we should be in the list, we just need to figure out what that value looks like. So we're going to let k equal the percentile that we're given. So if we're given the 75th percentile, k is 75. If I'm given the 30th percentile, k is 30. I is going to be the index. This is the location in the list that we're interested in. And then n, just like before, total number of data values. So just like before, we have to start with a sorted list. Then we're going to calculate where that data value should be in the list. So to find the index, the location where the data value should be found, we take that percentile ranking and divide it by 100. We're taking that percentile, turning it back into a decimal, and then we're multiplying it by the number of values in the list plus 1. And that's going to give us a location in the list. Where am I along that sorted list of data? And there's two possible outcomes. If, when you do this calculation, I is a nice pretty whole number, to find your data value, you start with the smallest and you count until you get to the ith position. And whatever number is at the ith position in the list, that's your answer. If I is a decimal, you want to round down and up. We're going to pick two values from the list. Find the value that's just below I, find the value that's just above I, and then find the midpoint. Add the values, divide by 2. So what we can see is sometimes when we're working backwards, I know the percentile ranking, but I don't know what test score that corresponds to or what height that corresponds to. Sometimes you're going to end up with an answer that's not in the original list of data, and that's okay. Okay, let's do some examples really quick. So listed are 29 ages for Academy Award-winning Best Actors in order from smallest to largest. And we're asked to find the percentile for the age 58, and then we're asked to find the age for the 70th percentile in this data set. What is the age that divides the lower 70% from the upper 30%? The nice thing, they said this is already sorted from smallest to largest. So they've done this first step for us. We are already sorted. So let's go ahead and start with A. We want to find the percentile given a data value. So that's the first process we talked about. So there's my 58. I need to identify 3 numbers. How many data values are less than 58? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18 are less than that. Y is the number of times that number appears in the list, and 58 only appears once, so Y is 1. And then there's 29 data values in that list as a whole. If I count every number in this list, I should end up with 29. Next, we're going to use the percentile formula. So our percentile formula is x plus 0.5y divided by n times 100. So 18 plus 0.5 times 1 divided by 29 times 100. And when I plug that in my calculator, I get 63.74. And when we state percentiles, we always state them as a whole number. So you should round any decimal percentile calculations to the nearest whole number. and 0.7 is closer to 64 than 63, so I'm going to round up to 64. So 58 is at the 64th percentile. What that means, looking at this list, is that 64% of the data in this list, this whole chunk here, is less than 58. That's 64% of the data. And then this chunk here represents 36% of the data, the complement to that 64. One quick reminder before we do the next part of that problem. If you choose to type this all in your calculator at once, make sure that you're putting parentheses around the top of that fraction. If you've got operations like addition or subtraction in the numerator or denominator, you need parentheses around the numerator or denominator. Okay, let's try let's try part B. Words are hard. Same list of data. They want us to find what age separates the lower 70% from the upper 30%. Again, our first step's done for us. They've sorted the list. The next step is to find the index. Where in this sorted list is that 70th percentile divider? To do that, we need to know what our percentile is, 70, and how many values are on our list, 29. And now I just need to figure out what 70% of 29 is. So our index is k over 100 times n plus 1, 70 divided by 100 times 30, 29 plus 1. And when I do that, I get exactly 21. Since that's a whole number, we know that we just need to go to the 21st number in the list, and that's our answer. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I'm getting 64 is the number at the 21st spot in the list. So the 70th percentile is 64. 70% of the ages of these actors are less than 64. 30% of the ages are greater than 64. Okay, I know this was a long video. Hopefully you watched it on like two times the speed, so you didn't have to sit here for very long. Again, I know this is complicated. Quartiles are important, percentiles less so. So if you have to cut back on something, cut out the percentiles. It's good that you know what they are. It's less important that you know how to calculate them. Again, if you have any questions, email, text message, office hours. Otherwise, I'll see you in the next video.